はい、それではですね、本日は、SIUK 主催の、オンライン、ウォーリック大学のコンピュータサイエンス学位コースについてですね、ウェビナーにご参加いただきましてありがとうございます。本日はですね、ウォーリック大学より、ユリア先生とシャド先生に、お越しいただきまして、ウォーリック大学のコンピュータサイエンス学位コースについて、プレゼンテーションをしていただきます。で、本日ですね、プレゼンテーションの最後に、質問コーナーも設けておりますので、もしご質問がありましたら、チャットボックスの方に、お送りいただけたらと思います。また、本日のウェビナーがですね、YouTube での同時配信となっておりますので、皆さんのカメラ、あとマイクですね、ご利用いただけませんので、何かご質問とか聞きたいことがある場合は、すべてチャットの方から、お送りいただけたらと思います。そうですね。あとは、開始後ですね、お名前、YouTube でのライブ配信となりますので、皆様の表示名を、変えさせていただきますので、よろしくお願いいたします。またですね、今日出席確認を行っておりますので、私の方にチャットで構いませんので、ご参加されている方のお名前ですね、を、後ほどで構いませんので、お知らせいただけたらと思います。はい、それでは、早速なんですけれども、プレゼンテーションを、開始していただきたいと思います。So, Yulia, over to you. Thank you.
Thank you very much, Hiroshi. Hello, welcome to Warwick in this virtual format. I will share my slides with you now. I hope you can see my slides. So today I would like us to go through some information about data analytic master course here at Warwick in the Department of Computer Science. There are two colleagues here from the department, so myself and Arshad. Arshad will expand a bit more about the program later, after I will give you the general introduction about our department and our infrastructure here and some information about the program. So as I mentioned, this is the main aim of this session. I will introduce you to Warwick, I will introduce you to our department, and also will highlight the key elements of our program, and hopefully we will have some time for questions at the end. So first of all, why Warwick? Warwick has a very strong reputation and in the UK and also internationally. We are a research-led university, and it means that we incorporate the research components in our teaching program. And if we look at the recent research assessment framework, research excellence framework in the UK, we were ranked the 4th in the UK in the national level amongst all computer science department. We are sharing this 4th position with the UCL, University College London. And in the recent university guide, we were ranked 8th for computer science discipline. So we're very strong nationally as well as internationally in the area of computer science discipline. But of course, it's not just numbers, there are people behind. So we have a strong group of academics here. We consider to be a middle-sized department. So we have about 55 academics here who are contributing to the teaching and research. As I mentioned, we're a research-led university. So most of our academics here, our colleagues, they're contributing to both teaching and research, and clearly their research will influence the teaching here in the department, especially at the level of the MSc. In the same time, we have a group of support staff and technicians. These colleagues are making sure that you're well supported with different things that you might come across during your usual academic life in the department. So clearly our technicians will support anything related to the technical equipment and computers in our labs, and the support team will make sure that all transitions are smooth with the submission of assignments, the exam proceeding, and so on. And we have a very large student community here, both at the undergraduate level and the postgraduate level. So in terms of the infrastructure here, the main building, it's computer science building. So in this building, we have a number of dedicated labs for practical and independent studies. So we have 3 labs on the ground floor of this building. I will expand a bit more on that. We have 2 teaching rooms for lectures and seminars in this building. In the same time, many of our modules have many students, and therefore very often the large lectures are scheduled in the different buildings around campus in the large lecture halls. And these 2 teaching rooms are primarily used for some modules with smaller number of people, under 100, and also for the small group sessions and seminars. In this building, we have 2 students' common rooms that can be used by our students during the breaks for informal interaction. Students might prefer to have some lunches during the breaks in these rooms and just have social interaction and engagement between them. And we have a student support office in this building. So this is the main computer science building. Recently, we also opened this new so-called mathematical sciences building. So this is the new 6-story building just behind the computer science building. And this building is shared between 3 departments: computer science, statistics, and mathematics. And clearly here we would like to promote interdisciplinary collaboration between different departments. And this is the great opportunity for us to be part of this building, which is shared between 3 departments. In this building, we have more lab spaces for undergraduate and postgraduate students, and also we have open plan study spaces, some rooms that the students can book for self-studying or preparing some group projects. And we have more offices for staff as well, and for academic staff and the support staff in this building. So just to give you a bit of the feel here in terms of these facilities. So if I briefly stop sharing my slide, and actually will share before that, sorry, I will just show you one more slide here because it has a website. So just to give you a better view, and in a moment I will show you a bit of this virtual tour, which was prepared earlier during COVID, as we couldn't have open days on campus. So you can see here, this is our main computer science building. Behind that, this is the mathematical sciences building. This is the new building shared between mathematics, computer science, and statistics. And on the right-hand side, you will see Mathematics Institute. So this is the mathematics department here at Warwick. What I also can mention here is that these are buildings actually connected. So if the weather is not very nice, and you might expect that in winter sometimes the weather is not very nice in the UK, you actually will be able to access mathematics institute as well as the mathematical sciences building without going outside. So there are connections here between these all three buildings. So as I mentioned, I wanted to show you a little bit of the virtual tour, just so you get some feel. And I'll just share this website. If we go and look at the computer science building, so I'll just show you a little bit inside of this building. So we have this atrium as the entrance into the computer science building. We have the office here for the support staff. And we have 3 labs here. So one lab is here on the right-hand side as you enter the building. Then we have the second lab here. So we actually can enter this second lab. These labs can be used by undergraduate and postgraduate students. And the important thing, these labs are open 24/7. So students have an access card to enter into the labs in our building and pretty much can use it anytime, wherever they want to use our facilities here. So this is our second lab, and here on this side, if you enter the building, on the left-hand side here, if you enter the building, then you will have the third lab. So this is the main computer science building. We have one image of one of the seminar room here. You can see the arrangement is done here as it was during the COVID time with the special distancing. So we have this room and the second room of the similar type. In this room, as I mentioned, we are lecturing some of the smaller modules in the department, as well as some of the seminars and small group classes. So if I now go back outside the computer science building and just move to this new Maths and Stat building. So this is the building just behind the computer science building. This is the new building I mentioned earlier that we are sharing with Maths, Stats, and Computer Science. And you can see here in this atrium, it's very much open plan. So there are different areas that the students can use. There are some labs here. We use the 3rd floor here in this building for some activities, and postgraduate students very often use the space here on the 3rd floor, as well as they have the common room here with small kitchen facilities that, again, mainly postgraduate students, our master students are using that facility in this building. So this is the kind of a brief overview of the facilities here, but of course you will be able to explore more using this virtual tour by yourself. So the session is recorded, so you will be able to sorry, again, I accidentally shared the wrong window. So I'm going back to my slides. So you can use the virtual tour by yourself and explore a bit more about our facilities as well as the campus overall. So what about beyond our campus? We are a founding partner of Alan Turing Institute. It is located in London, and we are a founding partner with Cambridge, Edinburgh, Oxford, and UCL. And this is the institute that was established a number of years ago specifically for data science and artificial intelligence. So you might ask why this might be important for me. What it means that we provide this scientific network collaboration, and clearly our colleagues who are engaging with the activities of this Alan Turing Institute, they're bringing interesting problems, projects into the department. You can engage more with the activities of this Alan Turing Institute, and this provides you the connection with the scientific research community in data science and AI, and also you might have a more interesting problems, hot topic problems for your research dissertation in connection with some activities of Alan Turing Institute. So again, in terms of our department, we have 55 academics. We have a team of technical and admin staff that are here to support you. We have about 170 research associates and PhD students in the department. We have more than 1,000 undergraduate students, and typically each year we have about 90 MSc students. These 90 MSc students, they are doing 2 MSc programs, computer science and data analytics. We are particularly focusing on data analytics students here, but in general, we consider these 2 cohorts as one group because they're sharing many classes and many modules. So in terms of our data analytics MSc program, so in this program, we are covering core tools, techniques and application in data science. And in this program, we combine the elements of computer science, business, engineering, and mathematics. So here you might focus on some more theoretical topics, and clearly you will be exposed into the foundation of data analytics, but also in the same time, you will be exposed to more applied side. So you have the opportunity to expand on machine learning, on sensor and wireless networks, different methods for data analysis, data visualization, and so on. So later today, Arshad will expand a bit more on some of the modules that we are offering here, and also he's involved in teaching one of the MSc modules at the moment, but in the same time, he was involved in a number of other modules in the past. So here for this program, we are looking for the technically minded graduates, the graduates who did the degree in computer science, maths or physics. Also students who did statistics, for them the course will be suitable. The only thing, if the students didn't do the computer science degree as their first course, we would like to see the elements of programming. So the students actually familiar with the programming, at least in one language, and will be able, in this case, they will be able to follow the program. I would like to expand a bit more about the structure of the academic year here at Warwick. So the master course, and it's typical for master courses in the UK, it's running for 12 months, so from October to September. It differs from the undergraduate courses that are actually finishing at the end of June. Here, the master students are studying beyond term 3, and they're studying over summer months as well. But they're working mainly on the research dissertation at that time. So we have 3 terms here at Warwick. Each term runs for 10 weeks. And during the first 2 terms, and they will be running from October till March, clearly there will be the Christmas break in the between. But during these 2 terms, the students will be focusing on the taught components of our program. So they will be doing the taught modules. The dissertation will start from January and will run until September. So the dissertation project is not term-based, and from January it starts be present in parallel to other taught modules that the students will be taking in term 2. In the same time, during term 3, this will be after Easter break. The students will not have any taught module components, but they will be doing the exams. And the project will be running in parallel during this time. So what we expect to see that we encourage the student to start thinking about the research project during term 1, and then they will be required to team up with the supervisor in term 2 and think and develop this project gradually in parallel to other elements of the program. During the exam time, clearly we can see the students are focusing mainly on the revision and the exams during some part of term 3, but as soon as the exams are over, the students are expected to work 100% on their dissertation. Clearly before that time, they already will be submitting some parts of the assessment for the dissertation project, but the main submission of the dissertation itself will be in September. In terms of the modules, for the taught element of the program, the data analytics students, they have 3 core modules that they need to pass, and also they have 2 required modules that they also need to take and pass to progress in this program. In this case, you can see dissertation as one of the core modules. So to get the MSc degree, the dissertation needs to be passed. And the other 2 modules will be research methods and foundation of data analytics. In addition, we have foundation of computing and data mining as the required modules. With this program for data analytics, the core components, in addition to these core components, the students can choose 4 optional modules. And we have a list of optional modules. Again, Arshad will expand on that later today. This is the main structure of the taught components of our degree. In terms of the research in the department, we have 4 research teams. One research team is focusing on AI and human-centered computing. We have a group focusing on applied computing. We have a group working in data science, systems, and security. And also we have a large group working on theory and foundation. So our colleagues from all these 4 research groups, they can be potential dissertation supervisors for your research project, for your research dissertation. We have also some collaboration with the industrial partners. So you can see here a few names mentioned. In the same time, we don't have a well-established connection in the way of integrating the external partners into the MSc program. However, if you decide to work with some academics here on your research dissertation, and this academic has connections with the external partners, this might be a natural possibility for you to collaborate with some our industrial contact through your supervisor that you might decide to do your dissertation with. In terms of the typical module, what you might expect here, each module will have about 2 or 3 lectures per week. So these lectures will be about 50 minutes. And the lectures are typically focused on theory. So they will be in the large lecture halls for the whole cohort. And as I mentioned, that might be scheduled across the campus. In addition to these 2 or 3 lectures per module per week, you will have about 1 or 2 small group sessions per module. It might be either lab sessions, they will be organized in the labs in the department, or it might be some sessions in the seminar rooms. So in this session, during these sessions, the students are focusing primarily on the practical aspects. So the focus might be on some practical exercises, but also some part of the sessions might be allocated for work on the coursework for the individual module. We usually engage our PhD students here in the department. They are our teaching assistants, and they will be helping to the main module organizers with running the seminar sessions and labs for different modules. And clearly, these are just the contact hours. We expect the students will be doing a fair amount of independent study. And there are different facilities here on campus for individual studies, for group studies, for completing the coursework, working on some presentations, and just as I mentioned before, socially interacting during the academic year. Here also in the department, we have the personal tutor support. So each student has a member of staff here from the academic group, and this personal tutor will be assigned to all students. And what we see here, that this pairing will be having regular meetings, which will allow the student to discuss the progress with your personal tutor, and also raise any issues that the students might have during the academic year. So personal tutor is the main first contact for each student during their time at Warwick. Here in the department, we also have the Student Staff Liaison Committee. This is the special forum for students and staff to discuss different aspects of the programs here in the department. So this committee will consist of some representative from academics, but also some representative from the student community. In general, these activities will give the SSLC reps a good opportunity to practice their leadership skills and management skills. So we always encourage our students to engage with the SSLC activities, just because this is the opportunity to actually strengthen your CV here when you're at Warwick through these activities. So if we look beyond the department, so Warwick is a campus-based university, so we are based outside the city and we have a large, very vibrant campus. And this campus pretty much can provide everything. So we have different facilities here, sports center, we have a campus health center, and the students are asked to register with the health center when they join Warwick. So if there are any medical issues, this can be addressed very efficiently here on campus as the first initial contact point. Also, there are different support is provided inside the department, but also outside the department. We have a very good career support center, and we have our own careers liaison. So this center will provide the support for our students in terms of future steps after they finish their degree here at Warwick. And they provide various support. They might help you with preparing your CV for your job application. They can help you with preparation for the job interview. You will be able to schedule one-to-one meeting with our colleagues in this career support center for individual advice. As I mentioned, we're a campus-based university. You will find everything here on campus: shop, restaurants, spaces for social activities, different sporting events. We have farmers markets. They are coming here weekly on campus during the term time. So the life on campus is very, very vibrant. We also have the largest art center here in the country, and it's based on our campus. So this is actually the only university in the UK with its own art center here on campus. And this art center is running different shows. There is a cinema here, so there are different performances. So it's again very convenient for the students here on campus to have the access to these facilities. And we are not too far away from more vibrant cities. So Coventry can be reached very fast using a bus. Leamington Spa is another area where many students trying to find accommodation during their time at Warwick. Birmingham can be easily reached by a short journey by train here from Coventry. And also you can get to London very efficiently. I think it's under 1 hour trip to get you to London. And in terms of the careers in general, we have a large Warwick alumni community, and you can meet our graduates in different positions around the world in different companies. This is just a snapshot of some company names where you can find Warwick graduates from computer science department. In terms of the entry requirements, our programs are very competitive. So we receive very many applications every year. And therefore, our entry requirements are quite high. So we're looking for the first class degree, or at least high to 1 undergraduate degree. As I mentioned, we're looking for the technically minded students who did their degree in computer science, mathematics, statistics, physics, and other relevant disciplines. There is a requirement on the English language here, as you can see. And the application process is very straightforward. So there is an online application form that can be filled in. And then later, you don't have to have all your documents ready at the same time when you're filling in your online application. You can submit the supporting documents later. So usually what we expect to see, the transcript with the marks from the previous degree, a CV, and the person's statement why an applicant would like to join our program here at Warwick. And you will be asked to name at least one referee to support your application. So you just need to provide a name in the online form, and then your referee will be contacted by Warwick and will be asked to submit the application, the reference letter. So this is the main introduction to our program. I will stop here and pass it to Arshad, who will expand a little bit more on the modules that we are offering here, and then we will be happy to take some questions.
Hello, everyone. Thank you very much for attending. So I will talk a little bit on what we offer here at Warwick in data analytics, and a lot of the things that I will be talking about will expand on what Yulia has previously said. So a quick overview of the MSc in data analytics. So we have basically 5 core modules, or as you just said, we have 3 core modules and then 2 required modules. And then, of course, students will be expected to take 4 additional modules, optional modules. The core modules basically introduces the foundations of computer science, or the foundations of computing, and then foundations of data analytics. So these foundational courses are intended to make sure that all students start from the same with the same background. So the foundations for computing, what we cover in this module, well, we look at algorithms, we look at the complexity of algorithms, we look at data structures. So how do you represent the data that you are trying to analyze? We introduce probabilities and statistics. So all the basics of computing is covered in that module. And then we move on to the foundations of data analytics, where we end up looking at the data lifecycle. How do you capture data to make sure that you have adequate data? Then how is data efficiently stored? So we look at databases and how do you make efficient queries? We look at all the mathematics that supports data analysis. So for example, we look at matrix operations, we look at probabilities and linear algebra. And then we move a little bit on to more machine learning and AI techniques, such as we look at supervised learnings. We look at a topic called unsupervised learning, where one of the topics that we cover is called clustering. We look at deep learning and also other challenges that typically we tend to encounter, such as privacy issues. So, and the third core modules that we cover that students will have to do is the project dissertation. So for example, in the past, students have looked at cybersecurity. For example, they may want to try to design an intrusion detection system. So you will have to analyze network traffic and then use machine learning to be able to develop a proper intrusion detection system. Students end up doing projects in finance, image processing. They develop recommender systems, among many, many others. We'll cover a couple of them later on. And then for optional modules, as Julia has mentioned earlier, there are quite a lot of different modules, but some of them, for example, we've got sensor networks and mobile communications. We've got image and video processing, high performance computing. Of course, when we're running data analysis, we need a high performance computer system behind, otherwise it will take a long time before we get any output. So we have high performance computing, and then for the more theory minded, we've got game theory, and then we've got also advanced computer security. So some of the modules are offered in the department, but students are also able to choose a couple of other modules from other departments. And interestingly enough, though we have a lot of modules, a lot of them complement each other. So for example, when you look at advanced computer security, because we end up having privacy issues when we do data analysis, advanced computer security will allow you to start looking at, for example, the use of cryptography to be able to maintain privacy of the data that you're trying to preserve. So I have designed and taught 2 different MSc level modules previously. So I designed the content for advanced security and sensor networks and mobile communications, and I have also taught high performance computing. So what happens is I will just give you a brief overview of what is it that I am currently teaching for sensor networks and mobile communication. So how is sensor network and mobile communication important for data analytics? Well, sensor networks, as the name suggests, you end up sensing the environment. You sense a lot of the data that is being provided, right? And unless you have the right architecture, right, data may not be captured reliably. So the notion or the importance of sensor networks and mobile communication is to make sure that we learn about the whole network stack to ensure that data is collected reliably, that this is the data that we can trust to be able to run data analytics technique on them. So how do you make sure that the data is collected reliably? Well, we look at different algorithms, for example, for routing the data to the right place so that the data can be stored. So for example, routing data to a database. We look at data link layer protocols. We look at transport protocols, among many others. So what is a data link layer? Well, when, for example, there are many sensors that are broadcasting messages, right, and or data, the content for the network, there is network contention. So which is similar to when different people are trying to talk at the same time. We look at what we call contention-free access. So where everybody takes turn, where all the users take turn to talk or to send data, or we call contention-based, where everybody tries to talk, and then when you end up noticing that there is someone else talking, then you end up kind of backing off. So we look at different aspects of how different users may access the network. And then, of course, we look at routing protocol. So, for example, how information is routed in the network. If the sensors are very widely scattered, then, of course, we look at what we call geographic routing. Other than that, if certain users will need to interact with each other, we look at what we call gradient-based routing. Otherwise, there are other kind of technique between what we call proactive versus reactive routing. It's all easy. However, when we look at sensor networks and mobile communication, what we end up seeing is all of them will have finite energy source. They are very often like your mobile phone. The energy source, so your battery, will have finite energy. So at any point in time, those sensors or your mobile phones may end up crashing. And when they crash, well, you end up losing a lot of information. And then all of a sudden, all the information that you have gathered for routing or for data link layer, you will have, users will end up having to get those information back again. And also, one of the important problem is when you have unreliable links. Very often when we end up looking at some of the algorithms, we assume that what we call links are reliable, the links are working properly. However, we all know if you have broadband at home, links are very seldom reliable. And we need to be able to understand how we end up making sure that the architecture works well. So for sensor networks and mobile communications, and in some sense, very similar to all other modules in the department, we have two different access components. We'll have an exam part, which typically will amount to 70%, right? And we have a coursework, which will amount to 30%. Those weights will differ from module to module. Some modules will have 50% exam, 50% coursework. Others may have 80% exam, 20% coursework. But by and large, most modules will have an exam part and a coursework part. So as Julia was saying earlier, for the exam part, all the lectures will introduce the relevant theory. We'll end up learning about the different algorithms, the different data structures, what are the pros and cons of different techniques, and so on. On the other hand, what the coursework allows us to do is to enable students to apply the theory that they have been taught onto actual case studies. So coursework for sensor networks and mobile communication will introduce students to state-of-the-art network simulators and testbeds. And the objective will be to implement some techniques, whether it is routing algorithm, whether it is different data link layer protocols, covered in class, and run simulations under different scenarios. Now, for such networks, different protocols work well in different scenarios, and very often the coursework will ask students to try to understand the limitations of different algorithms under different scenarios. And then typically students will have to write a small report to document the approach they've used and then the results that they have gained. And for this coursework, like we said, it will be assessed up to 30% of the total module. Most modules will have similar assessment structure, but the weights may differ. In the past, I have also taught computer security, and again, the assess part, the exam part was worth 70%, and the coursework was worth 30%. But in advanced computer security, what we teach cryptography, which is really, really important for privacy in data analytics. But also we teach system security. For example, we look at operating system security, network security, web security, to be able to enable students to understand, for example, the impact of malware on their system. And now we have ransomware. And in the past, we've had students doing projects along those lines. So for example, when you look at malware, students may want to be able to understand, is the pattern of execution indicative of, let's say, ransomware versus just normal malware. And then, of course, we teach novel topics such as Bitcoin and distributed ledgers. Bitcoin and distributed ledgers are basically kind of very, very recent and novel technologies that are that we teach here. And then, of course, we have the third core modules that we have that students will have to take, dissertations. Students will have to do a project that goes from January to September. The project is worth, like, in terms of credit points, it's worth 4 modules, right? And students doing data analytics, of course, they're interested in data analysis, in developing data science techniques to be able to do analysis. So in the past, I've had data analytics students. Well, what are the kind of projects that they do? Well, it's very wide ranging. I've had students doing projects on football. So for example, detection of change in tactics using in-match data. So for example, when a team will have more possession, we end up saying, oh, actually, this is what's happening. And then at some point in time, depending on what's happening during the game, there are different substitutions. We end up detecting a change in tactic. I've had students doing projects on cybersecurity. So for example, detecting malware for Android. or I've had students doing being able to understand the difference between ransomware versus general malware. So these are typical projects I've had for cybersecurity. This year, I have supervised a student on finance, so predicting cryptocurrency dynamics using social media. So for example, things that we were looking at is if you have an influencer saying a few things on social media, how does that affect the movement of cryptocurrency values on the market? And of course, there are many other projects that different colleagues in the department supervising data analytics students end up. So we have other staff members looking at potentially health-based techniques to analyze images to detect cancer cells. We've got staff members looking at being able to predict, to do prediction for recommender systems. So there are lots and lots of possibilities. How does it work? Well, students develop their own project ideas. So if you have a specific project that you want to do, or you've got a brilliant idea and you want to develop those ideas with a colleague, you are very welcome to approach them, and the colleagues will be very happy to develop that idea with you. Otherwise, if you don't really know what are the possibilities, every year staff members will provide a certain number of topics for students to choose from. So this will provide some kind of initial guidance as to what are the possibilities available. Students can do exactly the same project that has been proposed, or they may discuss with a staff member and do some variation of that project to make it their own or to suit them. So that's for dissertation, and like I said, dissertation is worth 4 modules. There are different aspects of that. For example, there will be different you have presentations, and then you have small report to write to be able to talk about the progress. But I think last week was the deadline for students to submit their project. So then, of course, like we said, it runs from January to September. So just to conclude, we teach a lot of modules here in the department that are geared towards data analytics. Either a module will involve data analytics itself. So for example, we teach natural language processing, which involves basically analyzing the structure of sentences and paragraphs completely, or we have modules that will support data analytics, such as advanced computer security. Thank you very much for listening. We're open for questioning. You can put your questions in the chat, or else if you want myself or Julia to handle your question, you're most welcome to tell us. Thank you very much.
Thank you very much for your presentation. Actually, I received a question from a student. Actually, the student graduated from a Japanese university, and then he studied, I think, political economics. And then after graduating, he's been working as a full-time. I'm not sure what kind of job he's doing, but he's quite interested in data science postgraduate course. And then in his undergraduate studies, he didn't take any modules related to data science. So his question is, based on the background, is it still possible to apply for the postgraduate course?
So I think in this case, I mean, we don't know the whole information. We need to look at the experience that the students did after they studied. So we need to see what they did and what the experience the student had after they finished their first degree, which is, it sounds like was not in the scientific discipline. Because our program would require the quite strong background in mathematics primarily, and some programming experience would be required. So this is not a trivial case, I think, and we need to look at the paperwork to assess.
Just to complement what Julia was saying as well. So if the student has done while working, the student has been able to gather enough programming experience, that will count as well. So the student doesn't need to have taken, let's say, a programming language at university, but if since leaving university that student has been working, let's say, in programming or in software, then that should be put in their CVs, and then we take all that into consideration.
Right. So if the student has like experience of using a programming software on his work, so maybe he might be able to.
Yes.
Right. Okay. Right. Thank you. So yeah, sometimes we get inquiry from students who don't have a background, like who don't have a degree in computer science or data science, but they are still interested in those kind of postgraduate courses. So, and then if they have like a work experience related to data science or computer science, they might be able to get offer for postgraduate course.
Yes, in this case, we're carefully looking at the paperwork submitted and clearly so the different experience will take the different weight in our assessment. So it's all decided on the individual basis, one-to-one basis.
Okay, thank you.
Yeah.
So
it's important that they have the relevant mathematical background as well, right? So it's not only about working in the right industry. So we need to make sure that they have the right mathematical background, and then other aspects such as how they end up getting programming experience. This we can look at, but basically we look at each student as a package. So how are they experienced enough to be able to come in and study at Warwick, and do they have the right background?
Okay, thank you. So in that case, is there any possibility that you're going to ask to have an online interview or something?
We don't do that. We have many applications. It's not really physically possible. And also we don't want to treat different students differently. So we make our assessment based on the paperwork submitted.
Basically, we have roughly like 90 places, and we tend to get over like 2,000 applicants. So it's impossible to interview each and every one.
Okay, thank you very much. And as for the reference letter, you need at least one name of referee, right? And then does it need to be academic, or can it be professional?
So if the applicants just finished the degree or recently has finished the degree, we expect the reference letter will be from someone from academia. However, we understand that sometimes we might receive some applications from the candidates who finished the study a long time ago. It might be difficult to get a reference letter from someone from their university. So in such situations, a professional letter from the current job or maybe some previous job, recent job, will be acceptable.
Just to add, sometimes we've seen as well students doing internships, so summer internships, and if they want to get a reference letter from their current employer where they're interning, that's welcome as well. If the person kind of gives us some deep understanding of what the kind of project the student has been involved in.
Okay, thank you very much. はい。そうですね。それでは、 今日のウェビナーの時間も、来てしまいますので、ちょうど今1時間経ちましたので、これ以上、質問も、いないようですので、本日はこれで、終了と、させていただきたいと思います。So actually, we don't have questions anymore, and then it's one hour past. So yeah, just a moment. 今、ご質問いただいた方なんですけれども、そうですね、ちょっとお時間が来てしまいましたので、もし弊社の方に、メールでご質問をお送りいただけましたら、こちらの方から後日、先生方にご質問させていただいて、それを後日ですね、回答をお送りさせていただけたらと思いますので、申し訳ないんですけれども、弊社の方にですね、メールでご質問を後ほどちょっとお送りいただけましたら、幸いでございます。はい。ちょっと今日がですね、YouTube での、同時配信となっておりますので、ちょっとマイクのご利用がちょっといただけない、ちょっと状況になっております。大変申し訳ないんですけれども、またですね、ちょっとご質問をメッセージ、メールでお送りいただけますと、大変幸いでございますので、こちらの、弊社の方にメールで、ご質問をお送りいただけますと幸いでございます。はい。そうですね。はい。それではですね、今日、皆様ご参加いただきましてありがとうございました。またご質問等ありましたら、弊社の方にですね、お気軽に聞いていただけたらと思いますので、よろしくお願いいたします。Thank you very much for your time today. And if we receive any questions, we're gonna email you later. Yeah.
Great.
Okay.
Yeah.
Yeah. Thank you very much.
Thank you very much. Thank you, Yulia.
Bye. Bye, everyone.